Thank you everyone for joining us today. Today our topic is flood impact maps, and I'll begin by land acknowledgements. We're thankful to be able to join you from the traditional lands of the Mississaugas of the Credit, the Anishinaabe, the Haudenosaunee, and the Wendat. Our guest speaker today is Professor Slobodan Simonovic. He's one of the world's leading authorities on application of system analysis to water and environmental management. We cannot wait to hear what you have to share with us today, Professor Simonovic. So I'll stop sharing my screen now and invite you to start your presentation.
Thank you. Thank you very much. Let me. I'm very pleased to be with you today and share a little bit of information about the recently made and published web-based tool that looks into flood inundation across the large regions like our country and provides some insights into potential change of inundation due to the climatic change. The title of the presentation is Juliet's work, so you will see that we are not talking so much about flood impacts. I will touch upon that, but we are talking about really flood mapping and flood mapping under specific conditions.
I will also invite everybody who has a question to just write down your question on the chat section, and I'll see it, and I will make the professor know about your question. Carry on. Sorry.
Okay, so my presentation will provide a little bit of introduction through the motivation for this particular work. Then I was planning to provide the introduction into methodology, because I think explaining methodology will help understanding a little bit better what are these particular maps for. And then I'll illustrate the implementation of the methodology and the use of the maps and the tool that allows you to view them. I'll end up with a few words about communication to general public and also the ideas that we will be exploring or in continuing this work. So the kind of key motivation is, I think, the very, very heavy emphasis on the climate change and the impacts of climate change due to the events that are kind of occurring around us, as well as due to the international efforts that kind of ended up in Glasgow last week during the meeting of all governments trying to establish the goals and find ways how to tame the changing climate through the mitigation or controlling emissions of greenhouse gases. In preparation for the meeting, the IPCC publicized for the first report as a part of the assessment report number 6, and that was a physical science basis. Just a review of over 14,000 different references dealing with questions of science of climate change. The reason I'm kind of repeating this is that for the first time in this particular report, the emphasis on a very strong connection between the climate change and extreme weather was very explicitly presented. So the Glasgow, you probably picked up some news went on, and the discussions are continuing, and we all hope that they will result in some action that will be affecting the future emissions and the future pathways for changing climate. The second part of the motivation came from somewhere in April. I think federal government announced $1.4 billion over next 10-12 years to extend the disaster mitigation and adaptation funding, and that part of that money, about $60 million, was or is supposed to be allocated to Public Safety Canada for continuing the work on finishing the maps for the high-risk areas. So the international effort, which was pointing out the link between the climate and extreme events, and nationally focusing on extreme events, extreme flooding in this particular case, and use of maps for helping the process of dealing with that. So these are the kind of two things that together contributed to my wish to bring the results of the research that I've been involved with for more than 10 years to general public. The final product was the flood map viewer that we are talking about today. You see one of the screens from the tool, and the tool was simply on purpose published at the beginning of the Glasgow meeting to kind of coincide with the emphasis on climate change, as well as unfortunately it preceded the terrible flooding events that the BC is going through, and now the East Coast as well. The response to this particular publication was, shocking to me, I must say. The attention of the newspapers. I was asked, and about 8 newspaper articles came out, 4 interviews with different radio stations, 6 TV participations and shows, and obviously that kind of look, I think the climate change issues and link to the extreme events in this particular case to flooding was of the interest of general, I think, population. I was also informed when the tool was published on November 3rd, within a week, we had approximately 97,000 visits to the tool by the general public and over 16 million hits. This is the graph that actually shows that. And you can see the first peak coinciding with the day after the publication of the tool, and then the second peak coinciding basically for the beginning of the flooding event in BC. The response was from this kind of obviously very high attention and positive comments to some very disturbing comments. About 3 or 4 days ago, I had a close neighbor ringing the bell on our door, coming to apologize to me for the comments that people were publishing on the Facebook after the publication of the tool. After the article in Vancouver Sun newspapers, I kind of went through a couple of comments, and one of this was obviously commenting on 400 private planes landing in Glasgow, and another one was raising the question, who is this loser, basically referring to me as the author and publisher of the tools. So in order to introduce myself, I decided to answer this question just a little bit. I've been in this field for a pretty significant amount of time. I'm senior researcher dealing with the water resources and risk, reliability, flooding, especially are in the kind of focus of my research. I had a number of research projects, over 70, advised 45 master's students, 24 PhD students, published a lot of publications, over 600 professional publications, 260 in the peer-reviewed journals, and 3 textbooks. The book on floods in a changing climate was translated in Chinese. The book on systems approach to managing disasters is translated in Chinese. The book on managing water resources translated in Farsi. My lab is also publishing the technical reports beside the publication and the papers. We try to provide detailed information about the things that developed within our research group, as well as the data, tools, programs, and so on. And these publications we have about 114 volumes published up to now. They're distributed through the Western University Library And library is taking kind of statistics from 2011. Approximately 108,000 downloads of these documents were recorded from 139 countries around the world, obviously indicating that this research has a wide interest. Last year, I was called to the fellowship of the Royal Society of Canada, and also I was appointed to the so-called Reuters hot list of 1,000 most influential climate scientists in the world, being the only one from the Western University. So I thought that possibly answered the question, who is the loser behind the work that I'll be talking about. So let me tell you a little bit about the project on developing flood inundation analysis or performing flood inundation analysis over the large regions. That is the part of the collaborative research supported by NSERC and reinsurance company Chaucer Syndicates. That particular project was focusing on developing methodology for high-resolution flood inundation analysis over the large regions, investigating the utility of the publicly available data, and investigating the changes in the floodplain regimes for the future periods. Inundation, flood hazard measured in the water depth, as well as the change in the frequency of the flood events. A number of people participated as researchers and support. This work was, as I mentioned, part of this project where we looked into 3 different hazards: floods, winds, and earthquakes. I was principal investigator on the project, and I was leading the part on the flood hazard. And the work that you are seeing now is basically outcome of that project. Here is the basically summary of the methodology. For floodplain mapping, we used as input the runoff information coming from the observations, and because when you are considering very large regions like Canada, the observations are sparse, and therefore we looked into other sources of data, and we used the runoff data from so-called the reanalysis products. The reanalysis products are combining the observations with the remote sensing, satellite observations, and everything else, and then in a gridded format provide this information for the whole globe. A number of these products are available. You can see the list here. I'm not going to go into details. And what we have done, we actually investigated the utility of all these different products as the generators of the runoff input into our flood mapping process. So for the runoff generated from these different products, we utilized the hydrodynamic model, which is known as a Kama flood model developed at University of Tokyo by Professor Yamazaki, who also worked with us during this process. This particular model is combining runoff information with a number of other important pieces of information that are affecting the flood plain inundation development, and as well as the calculation of the velocity and the flood depth, like flow directions, like digital elevation models, open street models, global water maps, which are separating water surfaces from land surfaces, and so on. So these are all the kind of input information that go into this calculation, and as outcome you obtain the river channel flood depth, the river channel flow velocity, and overland flood depth. This information is then kind of downscaled to 1 by 1 kilometer resolution inundation maps, and after the statistical analysis for the particular return period, floodplain maps can be developed that are corresponding to these different inputs. Since we were developing this methodology, we also performed some validations of the model, and in the process of validating the model, we used the observations and we use the existing floodplain maps, which are obtained through the much more detailed type of analysis. Just to kind of show Canada, the green dots are here indicating the locations where the observations of the runoffs are being made, and you realize that for 10 million square kilometers of the land, this number is really limited. And therefore, I think the reanalysis is a good source to combine with the observations and help us cover the whole region with the same level of accuracy. The bottom map is showing the 6 different basins that are used for the verification or validation of the model. The choice was basically made based on the availability of the maps that can be kind of compared with the maps generated through our methodology. So to summarize, the methodology starts with downloading the runoff information. At different station locations, we did the comparison between the observed and the reanalysis values, did the detailed correlation analysis to kind of be sure that the reanalysis data are capturing what is happening in Canada. And then fitting the extreme value distribution to the data helped us to extract a 100-year and 200-year flood or 200-year runoffs. And they are in a gridded kind of form, then processed through the hydrodynamic model into flood inundation or extent, water depth, and velocity. In gray, you see this additional steps that we performed to kind of validate. We kind of took from the Canada and clipped the maps for the 6 selected basins, and then we did the comparison between the detailed floodplain maps there and the model outputs. The evaluation is done by dividing the kind of water depth into 5 different categories, from low to kind of high, as well as using the 4 different statistical or performance type of criteria that are comparing how good are the model results compared to some benchmark values. And in our case, the benchmark values are where the maps in the 6 different basins. These performance tools are the hit rate, false alarm ratio, critical success index, and the error bias. You have the details, and in the documentation I'm going to list at the end of the presentation, these details can be easily located. So through this procedure, you arrive at something like this. This is a GIS tool that basically takes the outcome of our work. And as you can see, as the bluish areas across the country are basically the locations of the inundation for the 100-year floodplain. You can zoom in on the particular location. You can basically clip particular watershed, and this is how, for example, we did the validation and look at the inundations in different locations. This is an example of the kind of validation process for the Grand River Basin. What you see are the 100-year and 200-year flood inundations. The green dots or the green color represents the model. The red color, which is kind of appearing under, are the maps, existing maps, which are pointing out. And as you can see, there is no 100% overlap. Our model works on a much larger scale, and the methodology that I kind of briefly described is covering the whole 10 million square kilometers in the same way. Whereas when you do the detailed floodplain mapping in the river basin, you can do very detailed hydrologic and hydraulic analysis, take the river cross sections, and find out the inundations. That something that's not kind of possible on a large scale work. However, in spite of the fact that there are some areas of the of not full overlap. If you look at this performance matrices, the level of accuracy achieved by this global modeling is pretty high, over 80%. But leaving, 18–19% of the locations not properly captured through the methodology. So you got, I think, the brief overview of what the methodology was that is used for mapping and performing this mapping process. What I would like in this part to say are what are the typical uses of the maps like this. And I think this is, or through the communication with me after the publication of the tool, I think that was the main issue or the main question. The people were immediately starting to look in a very much detailed location of their home or house. I even got a phone call from someone in British Columbia after the flood who recently bought a house in the floodplain, asking what can I expect, in the future under the climate change. The tool provides much more and much kind of broader picture than answering the question at the level of the particular property. So the first kind of objective, or the first goal, or the first outcome of the tool, or the first implementation, is understanding the kind of overall flood hazard across the country. So this is like a map that shows the hazard measured in the water depth. The shades of blue are showing the level of depth according to the five categories that I mentioned, indicating that approximately 70% of the Canadian inundated territory is under the pretty high risk. You can very easily zoom into these particular locations, and you can actually, as I mentioned, you can actually come to the level of the individual property and seeing. I'm going to demonstrate later the tool, and you will see how that can be done. So this was the first implementation of this type of work. The second implementation is analysis of the potential impacts of the flood hazard. So the idea was that existing floodplain maps that are generated through this particular methodology can be overlaid with other pieces of information in order to assess the impacts. As an example, we selected to, for example, illustrate the population exposure to flooding across the country. We utilized the census data, divided this into 5 categories from very low to very high. And then basically for each census unit, we were able to document the impact, the potential impact of flooding under different flooding conditions or scenarios. What you see here are basically 14 years, because the population data is annual. And for these 14 years, we did a comparison. The red color shows the areas which are very highly, where the population highly affected by flooding, and blue areas less or very low impact of flooding. If you summarize this information, for example, we found that up to 4 million people across the country lives within the existing floodplains. And under the future climate scenarios, this number obviously can increase. And the third implementation, which I think it's probably most significant because that was the focus of our work, was to look at the climate change impacts on flood hazard and flood inundation across the country. We utilized the most recent climate information. The input into this graph is very much similar to initial graph that I did show, but instead of using the observations or reanalysis input runoffs, we use the information generated by the global climate models, which are developed by and for IPCC to provide the assessment of the various impacts of climate change, as well as the impacts of various mitigation policies on the future, especially global warming, temperature, as well as the change of other variables, climate variables. We utilize the most recent data. This data is within the coupled modeling, the comparison project phase 6. And we utilized, out of all the models, climate models that are available, 17 of them that were producing directly runoff information, because the runoff was the input into our process that was directly taken from the climate models into our methodology, into our process of calculating the flood inundation depth and velocity. The climate models are functioning on the basis of number of potential future scenarios. We selected 2 of these scenarios. These scenarios are trying to actually now, through the shared socio-economic pathways, SSPs, are trying to capture the potential change of kind of way of life, as well as all the activities that are contributing to emissions, especially emissions of greenhouse gases that are being reflected in the increase of the global temperature and the change of other climate variables. We looked into 2 of these scenarios. One that is kind of medium range scenarios. That will be the scenario that current activities on the climate change front are generating. And we also looked at one more conservative scenario of not doing much, and therefore exposing us to, you know, much more severe impacts of changing climate. We also divided the time to look at the 3 kind of temporal or time frames. One was to run these models on the kind of historical period, so that we can compare to benchmark information and the reanalysis type of work, and then near future between 2020 and 2060, and the far future between 2060 and 2100. So now we had a kind of, you know, for 2 scenarios each, that's 4 plus the historical, 5 different maps or 5 different procedures to perform the total calculation and generate the same way as, you know, originally, by combining within the hydrodynamic model with other data, generate the maps that are showing the change in frequency of flood events, the inundation extent, as well as the flood hazard, which is measured, as I mentioned, measured by the flood depth. So here are the kind of outcomes. The flood inundation. First, you see this. This is called a heat map that kind of shows by the color of red color what is the potential change. These are the different scenarios: near future, far future, mid scenario, and more extreme scenario. And if you look at, let's say, the Ontario streams, we are noticing, for example, that the inundation may increase up to 30% for the more severe, about 20–25% for the mid-range future kind of scenario. These are kind of aggregated results obtained from the calculation from the whole country, and selecting these particular basins, and then looking only the results within these basins. This is the table for the 100-year return period. You can have the same for the 200-year period. The second outcome is the type of information that we generated is the change in the flood depth or the flood hazard. And that's being done again. What you see here are the near future 4.5 scenario and 8.5 scenario. And obviously, with the more severe scenario, the color is becoming more red This is also for the for the 200-year return period. And if you look at in the shades of the colors, we observed the change in the climate hazard, the flood hazard, or measured through the flood depth, may be increasing up to 60% by the end of the 2100, and under this more severe scenario. The mid-range scenario, you see a little bit more yellow areas, which are kind of showing kind of change or the increase in the flood depth up to 20 to 25%. So these are all aggregated information and the numbers. And that's what I think this model is a very powerful tool for. And the final product in the analysis of the climate change impact is the change in the flood frequency. And again, for the different emission scenarios and 100-year and 200-year return period, what you see is the red color is the kind of increase in frequency, where the like a 100-year flood will be looking more like a 200-year flood today, or the 100-year flood today may look something like a 30-year flood in the future. So these areas, the reddish or the reddish, yellowish, orangey color areas where most of the Canadian population are the areas where the frequency is going to increase, and by increasing frequency, I think more frequent events like a BC or East Coast are possible. Okay, so that was a very fast kind of walkthrough. The methodology, the ways how we derive these maps, and the ways or the the main utility of the tool and the methodology. What I would like now to do is to show you, so the work was done. We did publish a number of reports and a number of papers in the professional technical journals, but that's a limited audience. And my very strong conviction was that these results are of the value for the more general public, at least to raise the awareness of the link between the climate change and the extreme events, as well as to kind of provide a more detailed information at different locations where this risk from more intense flooding or more frequent flooding can be observed across the country. So we added one more task on simply building the interface to show the results in a relatively friendly way on the web. We decided to demonstrate this tool. So I'll stop sharing so you can relatively easily see how the tool can be used. This is the landing page of the tool, and it's relatively straightforward for to use. What we have provided are the two entrance points, exploring the maps, as well as learning more about the methodology and what are the maps that are available and how this can be done. And then we provided also under the question mark here, or this link, user guide, helping users basically to go through all the tasks and screens that the tool can allow user to do. And we are also providing through the tool the opportunity to download all these maps, either for the whole country or for the selected region, of interest. So the user can relatively easily walk by selecting the option. I'll show you first, just how the exploring maps look like. We have immediately the options to see three different sources of maps here. The general maps are basically digital elevation models or the data for Canada, high and lower resolution. We have opportunity to show the drainage basins across the country, and we also incorporated the postal codes over. So these are potential overlays that can kind of help the user locate itself on the screen. The current condition maps there are 4 maps that are basically generated using the reanalysis data products, as I pointed out, as well as using the climate models for the historic period. When you move the cursor, you immediately get the information, what is this particular map and how is this map generated. And in the explanation of the methodology, there is a table that also provides the detailed information about each of the maps. The future conditions maps are now the maps that are kind of covering all the options that I mentioned, the close future and far future, the mid scenario and more extreme scenario. So these are all the maps, and they can be simply by clicking on one of the options brought onto the screen. Let me just walk you through each of the menu options. The exploration, the learn more option is, I think, important because the methodology is pretty unique, and also the information that's provided is available here. You can easily see, for example, what are the maps that I was showing. You can see the description of each step of the kind of calculation and computation. You can see what are the data sources, especially the climate models that we used. The links are provided to all the location where the data is, from which we downloaded the data. And also we incorporated the set of frequently asked questions to explain some of the basic terminology being used. And the Learn More section ends up with the references. I think there are 2 key papers that are available, as well as 2 Blue Book reports, which are going into details of the development, running the model, and generating the maps. The user guide is a detailed, basically walk through the tool. You can see the explanations for each page and each menu option, and how and what the different options mean. And I think this is useful for someone who is for the first time getting into the tool, kind of following the steps and the explanation. The selection of the region, the downloading the data, and here you arrive at the explanation how the data can be downloaded for either the whole country or the selected clipped region. So the user guide is, I think, very useful for the beginners or the initial. Let me quickly demonstrate tool I'm going to locate. Yes, I forgot to mention that we do have 2 different types of the base layers. This is a typical Google image, and the other option is so-called OpenStreet Maps that provides a very detailed information up to the property level. So when you zoom in, you can actually see the details. I'm trying to look at for London, where I am right now. And you can see by zooming in, we are getting to the street levels. So on the street levels, you get to the property levels. And that's all information that's available within the kind of OpenStreet. We have the choice of maps are relatively straightforward. You select what you would like to show, and that is immediately kind of being displayed. So these different shades of orange now are showing basically the surface of the land elevation. And you can kind of locate, you can make it transparent, so you can look at the particular location, you can click, and you will get the coordinates of the location as well as the elevation. This particular location is at 245.28 meters. So in the same way, you can show the other information. Let's say the postal codes are very popular. This is a very large file that takes some time usually to kind of process, and the same way you can kind of click on the location. Now you see you have additional piece of information, and that's the postal code where I located my interest to. Now, over these kind of basic maps, you can finally get into, floodplains and flood maps and show the flood maps. Different flood maps can be shown, and they are showing in the shades of blue, where the legend provides the kind of depth, and you can kind of find out what is the particular depth by comparing to the legend, or again, by simply clicking on the particular location, you have now additional information. We have additional information than the 100-year flood obtained by the reanalysis product. This is the map that I selected, map 102. The depth of water is 3 meters and 59 centimeters. That's the location of this particular postal code and that particular location. You can use the transparency functions very nicely here, and then you can actually see under what particular water depth, what location is affected, and that's the way how you can look at the details. In a similar way, we can look at the future conditions, and selecting the maps basically generate the information that will be corresponding to particular future scenario and particular time slot. You see now it's showing the particular map of 200-year return period for the ensemble of mid-range scenario and the time frame 260 to 2100, and the corresponding water depth for that particular location, the postal code location, and so this is the way how you can actually show all the maps. You can kind of combine the information in the way how you would like to do it. By selecting the options on the right-hand side here, you can make the capture the screen, and as well as you can kind of download the information. Right now, you see the download is available for all the maps for the full file, and the main reason being is that, oops, I'm sorry. I skipped what I wanted to show, just one more feature, and that's the so right now we didn't make any further selection. We were focusing on the particular region, but we were using the kind of detailed maps. What I wanted to show is one more feature, and that feature is here. That black box is the way of performing the selection of the region that you may be interested in, and the tool directly clips on now the information and provide you with the option for, as you can see now, downloading the full file for the whole country or downloading only for the selected region. I think this is probably sufficient for the kind of demonstration and opportunity for you to ask some questions. I would like just to finish, if I can, switch back to my presentation. Do you see the?
No, yes, I do. Yeah.
Okay. So to conclude, this is for the first time that I think the most recent climate information is used in analyzing the change in the floodplain regimes and the kind of future over the whole country. We have these two options for 100 and 200 year flood events that we generated the maps that are available through the tool. And also the opportunity to notice some kind of conclusions that the western and northern parts and some of the eastern parts are going to experience pretty significant change in the frequency of these events. This information now can be used to create a national flood hazard atlas for Canada. And after the completion of our project, I was approached by NRCan, and right now we are in the basically discussions how to continue collaborating together to bring this particular tool and the data and the maps into National Flood Hazard Atlas. Also, this particular, I think, analysis and tool is pointing out the regions where the more detailed, I think, floodplain mapping needs to be done in order to reflect the kind of higher risk that these particular regions are exposed to. And currently, the tool does not include the coastal areas and the coastal flooding because the nature and the mechanisms of the coastal flooding are different from what the hydrodynamic model is capturing in this work. And we would like that to be added because Canada, with three kind of coasts, has a considerable, or is experiencing considerable impact from coastal flooding. That brings us to the end. These are the kind of references. They're all available for download. They're all available on my personal website, and you can very easily also contact me in the case you would like or need more information.